The watermelon you know is a lie, not because it's fake, but because it's been completely rewritten by humans. The original watermelon wasn't sweet, wasn't red, and wasn't even meant to be eaten the way we eat it today. It was bred, reshaped, and transformed over thousands of years, from a wild African survival fruit into one of the most engineered foods on Earth. What if everything you associate with watermelon, the bright red flesh, the explosive sweetness, the clean seedless slices at summer cookouts, is actually the final chapter of a 6,000-year agricultural rewrite? To understand that transformation, we have to go back to northeastern Africa, long before supermarkets, sugar breeding, and anyone cared about crimson flesh. The species we now call Citrullus lanatus traces its origins to wild populations, growing in arid regions of present-day Sudan and surrounding territories. Archaeobotanical discoveries in Libya show watermelon seeds dating back roughly 5,000 to 6,000 years. But these were not dessert fruits, they were survival plants. Imagine harsh desert terrain, limited rainfall, brutal heat. In that environment, a fruit with high water content becomes more than food. It becomes hydration storage. Early wild watermelons likely had pale interiors, white, greenish, sometimes yellowish, and many varieties were not sweet at all. Some were even bitter. The appeal wasn't flavor, it was moisture. Here is a question that shifts perspective. If you lived in a climate where fresh water was scarce, would sweetness matter, or would survival matter more? Early communities weren't looking for candy. They were looking for hydration and nutrition. Seeds were central to that equation. Long before red flesh became valuable, watermelon seeds were roasted, dried, and consumed. They provided fats, protein, and calories in regions where those nutrients were difficult to obtain consistently. In some cases, seeds were pressed for oil. So the earliest known relationship between humans and watermelon was practical, not indulgent. It was a dual-purpose resource: water in the flesh, nutrition in the seeds. Genetic research has added clarity to this early chapter. The closest living relative to domesticated watermelon appears to be a melon from Sudan, commonly referred to as the Kordofan melon. Unlike other wild relatives that produce intensely bitter fruit, this Sudanese type produces non-bitter flesh. That detail is crucial. It suggests that the earliest domestication efforts focused first on selecting non-bitter varieties. Sweetness likely came later. Farmers weren't chasing flavor initially. They were selecting for edibility and hydration. By around 4,000 years ago, watermelon had entered cultivated life in northeastern Africa. Ancient Egyptian evidence supports this. Tomb paintings from the Middle Kingdom period depict oblong striped fruits that strongly resemble early watermelons. Seeds have been recovered from Egyptian burial sites, including elite contexts. That placement tells us something important. Egyptians placed food in tombs to nourish the dead in the afterlife. Watermelon was valuable enough to be included among those provisions. But here's the twist. Those Egyptian watermelons were probably not red inside. Artistic depictions and modern genetic reconstructions indicate that early cultivated watermelons displayed a range of flesh colors. Red flesh, rich in lycopene, became dominant much later through selective breeding. The iconic deep crimson interior is not ancient. It is the result of human preference reinforced over centuries. Ask yourself this. When did we decide that red meant ripe, red meant sweet, red meant better? That association is cultural, agricultural, and genetic all at once. As cultivation stabilized along the Nile Valley, watermelon spread outward through trade networks. Agriculture travels with people, merchants, migrants, and expanding societies carried seeds across North Africa into the eastern Mediterranean. By the classical Greek and Roman periods, texts describe large, watery fruits consumed in warm seasons. Greek sources used the word pepon, meaning something ripe or soft. Roman agricultural writers discuss melon cultivation techniques, including irrigation and seasonal timing. While terminology in antiquity overlapped among gourds and melons, most scholars agree that watermelon was circulating in Mediterranean agriculture during late antiquity. Domestication is not a single breakthrough moment. It is gradual refinement. As watermelon moved across regions, farmers selected traits suited to local conditions. In warmer climates, larger fruits with higher moisture thrived. Over generations, bitterness decreased, sugar content increased, texture improved, fibrous interiors became more tender. This was not laboratory science. It was observational selection. Farmers saving seeds from the best fruits, season after season. By the early centuries of the Common Era, sweeter varieties likely existed around parts of the Mediterranean basin. Hebrew texts from late Antiquity mentioned melons among desirable fruits. Roman manuals describe agricultural practices that align with melon cultivation. The trajectory is clear: incremental sweetness, incremental refinement. Then watermelon moved east. By the 7th century, cultivation had reached the Indian subcontinent. Climatic conditions favored its growth, long hot seasons with ample sunlight. From there, by roughly the 10th century, watermelon appears in Chinese agricultural records during the Song dynasty. Once introduced, it spread quickly across northern China. Summer heat made it a welcome crop, and over time it became deeply integrated into seasonal food culture. Think about that geographic arc. For a moment, a wild African dessert vine becomes a cultivated now crop, spreads through Mediterranean trade, enters South Asia, then establishes itself in East Asia, all before industrial transportation. How does a plant achieve that reach? Through human networks. Meanwhile, in the Islamic world, agricultural scholarship flourished. Medieval agronomists wrote detailed manuals on irrigation systems, soil management, and crop rotation. Watermelon was included among recommended summer crops. As Islamic territories expanded into the Iberian Peninsula, agricultural knowledge moved with them. By the 10th to 12th centuries, watermelon was cultivated in Al-Andalus, Islamic Spain. From there, it entered broader European farming systems. In medieval Europe, climate limited widespread cultivation in colder northern regions, but southern Europe embraced it. Over time, European growers continued selecting for sweetness and texture. Artistic evidence gives us a visual checkpoint. A 16th century Italian painting shows a watermelon with pale segmented flesh and prominent seed cavities, very different from the uniform red interior common today. That image confirms that, even 500 years ago, the transformation toward modern watermelon was still underway. Here's another key question. If Renaissance watermelons still look dramatically different inside, how recent is the fruit we recognize as normal? The next major shift came with the Columbian Exchange. After 1492, crops crossed oceans between the Old World and the Americas. European settlers carried watermelon seeds to the Americas in the 16th century. The fruit adapted quickly to warm regions in North America, Central America, and South America. Enslaved Africans in the Americas cultivated watermelon as well, drawing upon agricultural knowledge rooted in African traditions. By the 17th century, watermelon was widely grown in parts of the American colonies. In the United States, particularly in southern states with long hot summers, watermelon flourished. By the 19th century, it had become a seasonal staple. Seed catalogs advertised named varieties, signaling an increasingly organized breeding culture. Growers selected for larger size, higher sugar content, deeper red pigmentation, and transport durability. Agriculture was becoming commercialized. Color selection intensified during this period. The red flesh associated with modern watermelon comes from lycopene, a pigment also present in tomatoes. As breeding advanced in the 19th and 20th centuries, farmers increasingly favored high lycopene varieties. Consumers associated deeper red color with better flavor. Market demand reinforced that preference. Over time, red became dominant. Midway through this evolution, science took center stage. 20th century plant genetics introduced a revolutionary development: seedless watermelon. Contrary to popular myth, seedless watermelons are not genetically modified organisms in the modern GMO sense. They are typically triploid hybrids produced by crossing a tetraploid plant with a diploid plant. The resulting triploid plants grow fruit with undeveloped seeds because the chromosome sets do not divide evenly during reproduction. The fruit forms, but viable seeds do not mature. Ask yourself this: how far have we come from a dessert survival fruit harvested for seeds to a laboratory-assisted hybrid designed specifically to eliminate seeds? Seedless varieties gained popularity in the late 20th century, especially in the United States. Consumers preferred convenience. Farmers adapted production systems to accommodate these hybrids, which require specific pollination arrangements because they cannot reproduce on their own. This stage of watermelon history represents a fusion of ancient domestication and modern cytogenetics. Let's pause for a second. If you're into this kind of deep, evidence-based food history, the real stories behind everyday ingredients, make sure you subscribe and stay locked in. This channel breaks down how common foods became global staples, backed by research, not internet myths. Now let's keep digging. Beyond sweetness and seedlessness, modern breeding improved disease resistance and yield. Watermelon crops are vulnerable to fungal infections, viruses, and insect pests. Agricultural research programs developed hybrids that could withstand environmental stress while maintaining sugar levels and texture. Commercial production expanded across regions with suitable climates. Today, countries like China produce enormous quantities of watermelon annually, making it one of the most widely cultivated fruits on Earth. Despite global expansion, genomic analysis consistently traces domesticated watermelon back to northeastern Africa. DNA sequencing has reinforced archaeological findings, anchoring its origin firmly in that region. Earlier theories suggesting alternative origins have largely been set aside. In light of genetic evidence, culturally, watermelon took on distinct identities in different societies. In parts of East Asia, it became synonymous with summer refreshment. In Middle Eastern cuisine, it is often paired with salty cheese, balancing sweetness and salt. In the United States, it became embedded in seasonal traditions and outdoor gatherings. Yet beneath cultural variation lies a biological constant. This fruit is the outcome of long-term human selection. From pale and possibly bitter dessert fruit to sweet red global commodity, that arc mirrors the broader story of agriculture itself. Domestication reshapes plants at the genetic level. It alters sugar metabolism pathways, pigment production, and reproductive structures. When we look at watermelon today, we are looking at thousands of years of cumulative human influence. Here's the final question that reframes everything. How many other foods in your kitchen have undergone transformations just as dramatic, without you ever realizing it? Watermelon's sweetness was engineered through selection. Its color was amplified through breeding. Its seeds were reduced through chromosomal manipulation. Its distribution followed empires, trade routes, migrations, and scientific institutions. This is not just a fruit. It is a timeline of civilization. The next time you slice open a watermelon and see that vibrant red interior, remember that you're not just cutting into a refreshing snack. You're cutting into 6,000 years of agricultural decision-making. From ancient African deserts to Egyptian tombs, from Mediterranean farms to Asian fields, from colonial trade routes to modern genetic labs, that journey lives inside every bite. If this changed the way you see a simple summer fruit, imagine what happens when you start questioning the history of everything on your plate. Stay curious, stay critical, and subscribe for more deep dives into the foods that built our world. Because once you understand the history behind what you eat, you never look at it the same way again.